This is the first of 3 lectures on applications of Newton's laws. This lecture will focus on friction and what it is and how to calculate it. Consider 2 surfaces that appear perfectly smooth. At the atomic level, the surfaces are not smooth at all. When one surface tries to move over the other, this is what creates the resistive forces we call friction. There are 2 types of friction. Static friction is at the beginning of motion, and kinetic friction is during motion. Have you ever tried to move a dresser in your bedroom? It is always harder to get it started than to keep it moving once it starts. This is because static friction is always higher than kinetic friction. Friction in general depends on the normal force acting on the object. The more the surface pushes against the object, the higher the friction. Also, the smoothness of the surface is important. The coefficient of friction, or mu, is a measure of how rough the surfaces are. It is a constant and has no units. It is simply the ratio of the friction force to the normal force. For example, a mu of 0.5 means the friction force is half of the normal force. Table 6.1 gives a list of kinetic and static coefficients of friction. Note that mu k is always smaller than mu s. Kinetic friction is also independent of speed and area of contact. The static frictional force keeps an object from starting to move when a force is applied. The static frictional force has a maximum value, but may take on any value from 0 to the maximum depending on what is needed to keep the sum of forces 0. So, the force of static friction, Fx, max, is equal to the static coefficient of friction, mu, times the normal force. And static friction is independent of area of contact and relative speed. A 100-kilogram box sits on a table that has a coefficient of static friction of 0.4 and a coefficient of kinetic friction of 0.2. How much force is needed to start it? Well, you have to overcome static friction to start it. The static friction is mu s times Fn. Plugging in, we have 0.4 times 100 kilograms times 10 meters per second squared gives us 40 newtons. How much force to keep it moving at a constant speed? To keep it moving at a constant speed, one must only apply enough force to overcome kinetic friction. Kinetic friction is mu k times Fn, which is 0.2 times 100 kilograms times 10 meters per second squared, or 20 newtons. If 50 newtons is applied to it, what will its acceleration be? Well, remember that once it starts moving, the friction acting on it is kinetic. So if we apply Newton's second law, we have the net force equals mass times acceleration. The net force is the sum of all the forces, the applied force and the friction force acting on it. So Fa minus Ff equals Ma. It's moving, so for Ff we'll use kinetic friction. 50 newtons minus 20 newtons equals 100 kilograms times A. A equals 0.3 meters per second squared. A box slides down a 30-degree incline that has a coefficient of kinetic friction equal to 0.2. Draw the vector diagram and find its acceleration. The diagram below represents all the forces acting on the block. F parallel causes it to slide down the incline, but Ff will slow it down. The friction force is dependent on the normal force. Remember, the normal force is equal and opposite to the perpendicular component of weight, so it is not just mg. To find the acceleration, we must apply Newton's second law. The net force that causes it to slide down the incline will be F parallel minus FF. Remember, the normal force is mg cosine theta, and FF is mu times Fn, or mu times mg cosine theta. And remember, F parallel is mg sine theta. Plugging into net F equals ma, we get F parallel minus FF equals ma. Mg sine theta minus mu mg cosine theta equals ma. Note the mass cancels, and using 10 meters per second squared for gravity, we get 10 times sine of 30 minus 0.2 times 10 times cosine of 30. That will give us our acceleration of 6.7 meters per second squared. A box slides down an incline of 20 degrees at a constant speed. What is its coefficient of friction? In this case, it's traveling at a constant speed. If it's at a constant speed, A equals 0, which means that F parallel has to be equal and opposite to FF. So mg sine theta must be equal to mu mg cosine theta. The masses cancel out, and mu equals g tan theta, or 10 times tan of 20, which is 3.5 meters per second squared.